The first video in our unit on the science of matter is on the puzzle and we have two learning targets here. We want to be able to explain why all matter has different properties and also differentiate between the macroscopic and submicroscopic levels of matter. First, some definitions that we want to be familiar with. Chemistry. We are studying chemistry, so we kind of want to know what it is. It is the science that investigates and explains the structure and properties of matter. When we talk about structure, what we're referring to is the composition and organization of matter. In other words, what it's made of and how it's put together. Properties. These describe the characteristics and behaviors of matter. Matter is anything that has mass and takes up space. Mass is a measure of the amount of matter an object contains. So now that we have an idea of some of the basic definitions, let's look and see how the structure and behavior of matter relates to matter's properties. And you might want to refer to figure 1.2 on page 5 in your textbook throughout this discussion. Question: would you sprinkle water on your popcorn instead of salt? And the answer is of course not, because salt and water have very different properties. Now the question is why? Why is it that salt and water have different properties? Well, simply looking at a model or a schematic of the two substances would tell us why. Salt is made of sodium and chlorine. Water is made of hydrogen and oxygen. So that gives them very different properties because they're made of different things. Next question. Would you take sucrose, which is table sugar, instead of aspirin if you had a headache? And the answer is of course not. Sucrose, or sugar, and aspirin have very different properties. Why? Well, it's not quite as simple as the water-salt example, because both sugar and aspirin are made of carbon, hydrogen, and oxygen. They're made of the same elements. However, if we look at the structures of the two, the picture on the left being the picture on the left is sugar, and the picture on the right here is aspirin. We can see that they have very different structures. Even though they're both made of carbon, hydrogen, and oxygen, there's different numbers of atoms, and those atoms are put together very differently. That gives the two substances very different properties. Next question. Aspartame and saccharin are both artificial sweeteners, even though they're made of different substances. The question is, how can this be? If they're made of different stuff, how could they have very similar properties? These are two very common artificial sweeteners. Well, here are two pictures, the one on the left being aspartame, the one on the right being saccharin. And you can see that the structures are in some ways similar. Take a look at this part of the aspartame molecule and kind of this part here of the saccharin molecule. You'll notice they have a similar structure. Actually, this structure here that you see, the six-sided structure with the double lines in it, is actually a benzene ring. That's something you would learn about in organic chemistry if you ever took that. But the shapes of the molecules are quite similar because of the similar structures, which means they're going to interact with your taste buds in a very similar manner, which means that they will both have that sweet taste that we associate with them. So the whole point of all this is the properties of matter are determined by the composition and the structure of that matter, what it's made of, and how those atoms are put together. Many of these properties we can just observe directly. We can look at the color of a substance, its physical state, solid, liquid, gas. Is it hard or soft? By touching it or how it interacts with other matter, you can determine that. Does the substance dissolve in water? Is it soluble? Or any other liquid for that matter? Does it burn in air? Meaning, is it combustible? What happens when it's mixed with another kind of matter? Is there some sort of chemical reaction that occurs? Or does it not? Is it very inert or non-reactive? So we can explain why matter has different properties based on its structure and composition. Next thing we want to do is we want to differentiate between the macroscopic and the submicroscopic levels of matter. And basically, just some issues we want to be familiar with here. So observations, they can either be macroscopic, and really all observations are macroscopic, meaning what we can see, what we feel, what we taste, what we smell, what we hear. These are macroscopic, that's a macroscopic view of matter. All observations are macroscopic. These macroscopic observations are determined by the submicroscopic structure of matter. When we were looking at the pictures earlier of salt and water, we can't observe these directly. We can't look at a molecule of salt or water and see these. It's too small for the human eye to see. It's even too small for the most powerful microscopes to see directly. However, we can infer them from our macroscopic view by knowing what these observations are, by knowing what we see and feel and hear and taste and smell. We can infer, we can decipher what these submicroscopic structures are. And it is those submicroscopic structures that determine our observations.